Let's talk about some classes that you'll definitely find helpful going forward. In the past, we've used the scanner class. That's been one of the main classes that we've used to help us actually write programs that do useful things. Okay, and the methods we've called typically are like nextLine and nextInt and nextDouble. Here are two classes that we're going to find really, really useful going forward. First is the math class, and that just has lots of helpful math stuff like absolute value, exponentiation, square roots. And then there's the random class, which allows us to define random objects. And those we can use to pick random numbers. Let's take a look at a couple of the method signatures of the methods in the math class. So remember, this here at the bottom is the general format of a method signature. And you can see these ones all have the keyword static. Okay, we're going to come back to this in a second. But for now, just notice that it's there for all these methods, but ignore it. They all have a return type. So in this case, if we're looking at the absolute value method, well, the return type here is integer. And you can see that's this first absolute value method. So this one returns an integer. Then we have the name of the method. So in this case, it's ABS for absolute value. And finally, we have the parameters that it takes. So this absolute value method takes a single parameter, one integer, and we call it x. There are actually two methods that are both called ABS for absolute value. What's the difference? Okay, you can see their return types are different. This first one returns an int, this second one returns a double, and their parameters are different as well. This one takes an integer, this one takes a double. We call this overloading. We would say the absolute value method, the ABS method, is overloaded. They have the same name, but different parameters. That's how the compiler can tell if we call the ABS method which of the two to use. It can tell based on what we pass in. And you can see based on what we pass in, something different will come out. In this situation, the return type happens to match the parameter type. So this version of absolute value takes an int and returns an int. This absolute value takes a double and returns a double, but it doesn't have to be that way. The only way we can tell the difference is if the parameter types are different. And the parameter types and the return types don't have to match. Okay, again, we call this overloading methods. And this is really helpful because it means that we can define two different versions of the absolute value method, one of which takes a double and can handle it, and the other of which takes an int and can handle it. And it's almost as if we can use those two versions of the absolute value method interchangeably. We could pass in an int, we could pass in a double, doesn't really matter because they're both called the same thing. But we know that actually, based on what we pass in, our inputs are handled differently because we're calling different versions of this overloaded method. Okay, now let's review for 1 second. Remember, we have these two buckets of data in a Java program. We have primitive data types like ints, like chars, like booleans, like doubles, and we use operators to work with those. We also have objects like string and scanner, and if you remember from that example, Iron Man suits. Okay, and we take those objects and we call methods that are defined for them. So we can use a scanners method, for instance, nextLine, and we can use a strings method, for instance, length or char@, or equals. So if we go on and we take a look at the method signature for the square root method, now remember this is from the math class, the square root method, there's a reserved word here that looks unfamiliar. It's the static reserved word. The rest of this looks similar to stuff we've seen before. Okay, the square root method takes a double as an input and it returns a double as an output. Labeling this method signature as static basically means, whereas with a scanner, we have to have a particular scanner object, a particular instance of the scanner class in order to use scanner's methods, if we label a method as static, it means that we can call that method without creating an instance of a class, without creating an object. So the programmer who wrote the math class basically said, hey, I want to make it so that you can use the square root method just by using the math class. You don't have to create a math object. That's what making a method static means. So if you're calling a static method, the call is going to look something like this. Class name dot method name. So whatever class that method is defined in, instead of using a particular object, a particular instance of that class here, you'll just use the class name. Okay, so an example looks like this. If we're given the area of a circle and we want to compute its radius, well, we'll base it off the formula area equals pi r squared. We start by declaring one double called area, and that's initialized to 10 square units, and we'll declare a radius. Well, radius equals math.square root of area divided by math.pi. we're not using an instance of the math class. We're using the math class name itself, math.squareroot. This is real different from in the past when we've used an instance of the scanner class and we've named it, say, something like reader. Here, because of the way these methods are defined, we're able to use just the class name of math itself. Okay, so math.squareroot of area divided by math.pi. Now, also in this example, you see that math.pi. That means that the math class has an approximation of pi that we can use. And you can tell based on the way it's written, this is actually a constant. This is a final variable. Okay, we'll get in a little bit more detail about how exactly that's structured in the math class, probably in a week or two. But for now, know that you can access that variable using math.pi, again, with the class name itself, not an instance of the math class. Real quick, here are some examples of the other methods that we defined back there in the math class. This is only a small sampling of the methods that are actually in the math class, but these are the ones that appear on that slide back there. You can see we have an integer called m, a double called x. Okay, if I take the absolute value of -7, then I get 7 stored in m. If I take the absolute value of -7.5, then I get 7.5 stored in x. Okay, likewise, math.pow of 3, 2. Pow is the method that we use for exponentiation. It takes 2 parameters. So in this case, the 2 arguments that we pass to it are 3.0 and 2.0. And that means we're calculating 3 to the second power, which equals 9. So now that's what's stored in x. Likewise here, we can pass a fractional exponent as well. So 16.0 to the 0.25 power equals 2.0. Okay, so that's taking a fractional exponent. In other words, that's like taking a fourth root. The max method returns the maximum of 2 numbers that we pass in. So here we're passing in 2 integers, 20 and 40. And what gets stored into m is the larger of the 2. So that's 40. Min does the same thing, except it takes the minimum. So here, min of 20 and 40, 20 gets stored into m. Now, when we use the round method, if you go back to the method signature, round actually returns a data type called long. Now, we haven't talked much about long, but basically all we need to know is that in Java, ints are 32-bit integers and longs are 64-bit integers. So that means that this method, round, takes in a double input and it returns a long input. That means that later, after we get that long return value back, if we want to store it into an int, we have to cast it, because otherwise we're trying to cram a larger, more inclusive long into a smaller, less inclusive int. The second really important class that we'll talk about today that's going to be really helpful is the random class. Okay? The random class basically lets us use random values. One key thing is you got to import the random class. It's in the java.util, just like scanner. So this is the import statement you'll have to have. These are the method signatures for 2 important methods of the random class. This is int, nextInt, intN. So the nextInt method takes an integer n and it returns a random integer from 0 to n minus 1. So that means if I input 5, it's going to return a random integer from 0, 1, 2, 3, or 4. Okay. Next double takes no inputs, takes no parameters, and it returns a double between 0.0 and 1.0. Okay, now 0.0 is inclusive, 1.0 is exclusive, so it can't actually return exactly 1. We don't have the static keyword here. So do you think you need to make an actual instance of the random class, or can you call it in the same way you called the math methods? Okay. And the answer is yes, you do have to make an instance of the random class, because those methods are not declared as static. So if you try this, open up a fresh class in Eclipse, include your random import statement, create a new random object. I like to call mine generator because that's what random objects do. They generate random numbers for us. And you can actually include this line of code. Print generator.nextInt3. It's going to return a random integer that's either 0, 1, or 2. If you run this program a couple of times in a row, you'll see you'll get different outputs. Okay, before you close up shop, a couple things you want to make sure you have a handle on. Number 1, you want to be able to use methods in the math class if I give you their signatures. You're going to use these so often that at some point you're going to have them memorized. But for now, I'll give you the signatures. Just make sure you can use them. You want to be able to know what exactly method overloading is and give me an example of method overloading. In particular, be able to tell me how exactly the compiler can tell which version of a method we're calling. It can tell based on the parameter type that we pass in, the argument that we pass in. What are static methods, and how do we access them differently from non-static methods? Okay, that looks like the math class. Those methods that are defined in the math class are mostly static methods. Means that we don't have to create an instance of the math class. We can call them just by using the math class name. Last of all, you want to be able to instantiate a new random object and use it to generate random numbers. Okay, we have those two different methods. One gives us a random integer based on the argument that we passed in, and the other gives us a random double between 0 and 1. Both of these classes are going to be super useful to us, and I think you're going to enjoy using them.